Okay, we'll now look at question 2, which deals with the different bond strength of covalent bonds. So if you look at the overview again, okay, we are now at this part, factors affecting the strength of covalent bonds. Okay, so basically there are three main factors that affect the strength of covalent bonds. So the first factor will be size of the atom, multiplicity of the bond. Okay, so that means whether the bond is single, double or triple. Okay, and then something called the polarity of the bond. So strength of the covalent bond is reflected by bond energy. So be careful of the terminology here. Okay, bond energy is strictly for covalent bonds. Okay, we never use bond energy to refer to ionic bonds. So now we look at the first factor, which is size of the atom. Okay, so basically a smaller atom means that the two atoms can approach one another more closely. So this will allow for a more effective overlap of the orbitals of the two atoms. And as a result, the bond form will be stronger. So if you look at the first two values, compare CH and CC, you'll find that CH bond is stronger than CC because the hydrogen atom is smaller than carbon. Okay, the next factor that we are dealing with will be multiplicity of the bond. Okay, this one I think is quite obvious. Right? Obviously, a double bond will be stronger than a single bond because there's an extra bond to be broken. Then similarly, a triple bond will be even stronger than a double bond. Okay, what I want to take the opportunity to go through here will be what is meant by sigma and pi bonds. Okay, so sigma and pi bonds differ in the way that they are formed. So if you look at sigma bond, okay, if the two orbitals overlapping are p orbitals, then that's how they overlap to form a sigma bond. So this is what we call a head-on overlap. Okay, this is the direction in which the orbitals are approaching each other. Pi bond is formed from a different orientation, is formed from the sideway overlap. Okay, so you can see for yourself the different orientation for pi bond. So the thing to take note of is if you see a single bond, it's definitely a sigma bond. Okay, now if you see a multiple bond, one bond will be sigma bond and the rest will be pi bonds. So like in the example we have just now, the CC double bond consists of one sigma bond and one pi bond. Then if you have a triple bond, it will consist of one sigma bond and two pi bonds. Okay, then here I also want you to notice the values. If you look at the value for a double bond and a single bond, okay, can you see that the double bond is not exactly twice the value of a CC single bond? What is the reason for that? Okay, it's because the sigma and the pi bonds, they have different strength. Okay, so a pi bond is actually weaker than a sigma bond. Okay, because the side-on overlap is not as effective as the head-on overlap. And as a result, you also see that a double bond is less than 2 times a single bond. Right, 610 compared to 350, you can see that a CC double bond is less than double the single bond. Okay, because the pi bond is weaker than the sigma bond. Okay, finally, we look at the last factor that affects our covalent bond. That will be bond polarity. Okay, basically in a polar bond, the electrons are not shared equally. Okay, and this is due to the atoms having different electronegativities. So if you look at C and O, O is actually more electronegative than carbon. Okay, now electronegativity simply means the affinity that the atom has for the electrons. So in other words, here the oxygen will attract the electrons in the covalent bonds more closely towards itself. Okay, so because the electrons now are closer to oxygen, this oxygen will have a slight negative charge. So we represent that with delta minus. Then the electrons are slightly further away from the carbon, so carbon will have a slight positive charge represented by delta plus. So there's now extra attraction between the delta plus and the delta minus. So that's why a polar bond will be stronger than a non-polar bond. So if you look at CC double bond, both are carbon atoms, so definitely there's no difference in electronegativity, so you don't have delta plus, delta minus. Okay, then you should also be familiar with what atoms are generally more electronegative. Okay, so generally there are atoms found at the right hand side and at the top of the periodic table. Okay, basically this part of the periodic table is where the non-matters are placed. Okay, so you know that non-matters usually they will gain electrons to form anions. So in other words, the affinity for electrons is high. Okay, so non-matters will be more electronegative than matters. Okay, so some of the common atoms that are more electronegative will be N, O, F, and other halogen atoms like chlorine, iodine, and so on. So once you see them, you should realize that they are usually more electronegative than the other atom. Okay, then I have a question here. Now, is the CH bond polar or non-polar? Okay, so I know that we have two different atoms here, carbon and hydrogen. Okay, but the difference in electronegativity of these two atoms is very slight. Okay, so CH bond is generally considered as non-polar. Alright, so in general, if you see two different atoms, usually you can assume that the bond is polar. Okay, but CH is the only common exception that you need to know. Right? CH bond is non-polar. It is usually found in organic compounds. Okay, so you need to be familiar with it. Right, so that's for question 2.